Welcome to Archaeversity online classes. In this lecture, I am going to explain you how to calculate, analyze and interpret one sample runs test for randomness using IBM SPSS statistics. In survey research, many of the times it is not possible for us to collect the data from the population. Instead, what we do is we collect the data from a small sample and we analyze it and try to infer these results to the population. So when you are inferring, we call this as an inferential statistics. One of the key assumptions of inferential statistics is that the sample should be drawn in a random. In the sense, the randomness of a sample plays an important role in inferential statistics. So how is it you are going to measure the randomness of one sample is using a one sample runs test. So I explained this one sample runs test using two examples from a real life scenario. Quite often in research, we may be interested in finding out whether the sample is drawn at a random or not. So this will help us to generalize the results drawn from a sample to the population. Now for this purpose, we use a runs test. When we say a runs test, in a runs test, a run is defined as a series of like items. So here we can see that series of like items. So 1, 2, 3, 4, 5 zeros. This we say as a R1, that is a run 1. So and these 4 ones are considered as R2, run 2, run 3 likewise. So suppose if you ask your respondents whether they have a bank account or not, and you ask questions like yes, no. So for yes you assign 1 and no as 0. So suppose the customers are arriving into a branch and you started asking them the questions. So continuously 1, 2, 3, 4, 5 customers says that yes. So this is one run. Then the 2 customers says no. This is the second run. Then there are 3 customers or 4 customers who says yes, third run. So there is again 5 customers who says no. So each of these are called as the runs: run 1, run 2, run 3, run 4. Or you can say a classic example of a runs test is your tossing a coin. So if you have a head, then head, then head. This is run 1. Then you have a 2 tails. Then this is a run 2. Then followed by H1, H. Then this is a run 3. So these are what we call as a runs, series of runs. In one sample runs test for a randomness, we try to calculate the randomness using the runs. So if there is similar kind of these things, you can say that there is a randomness. Suppose if you find that 1, then equal number of zeros, then equal number of yes, no's, then we can say that there is a pattern. So if there is a pattern, then there is no randomness. If there is no pattern, we call this as a randomness. So here the importance of this test is that the assumption of randomness is important in parametric statistical tests as well as non-parametric, especially in your inferential stats. So in inferential statistics, randomness is very, very important. This is a basic assumption. Unless otherwise your data is randomly selected or having a randomness, you may not be able to infer the results to the population. Then this one sample runs test checks for the assumption of a randomness. Then the test assesses the dictomous values only, that is yes, no, or head, tail, then pass, fail. Likewise, only dictomous values are considered in run test. If you are measuring something on a interval scale like a 1, 2, 3, 4, 5, then you can make a cutoff point. So anything below the cutoff point is considered as one series, and anything other than the cutoff point is considered as a other. So you can then these two are coded, like these values less than a cutoff point is coded as 0, and the values above cutoff point as coded as 1. So this way also, even if you have interval scale also, then also you can run the runs test, but you need to convert the values into a dictomous using a cutoff point. So the hypothesis that we frame in a runs test is that the sequence is random. In the sense that whatever the data that you collected, your observations are random. And the alternative hypothesis is that the sequence is not random. When we say that the sequence is not random, then you find a pattern over there. So pattern may be an uptrend or a downtrend or something like that, but it is not a random walk. So the requirement is that the variable or attribute to be assessed by the run test need to be a dictomous, measured on a only 2 points, yes or no. If the data are interval, a cutoff point be specified. Then the cutoff point may be a mean, median, mode of the distribution values. Using those values, you will convert the interval scale into a dictomous one. So here are examples. First we look at the first example. So here a manager of a toll plaza on a national highway wanted to know whether vehicle arrivals are random or is there any pattern before he runs some inferential statistical analysis. To know this, he classified vehicles into two categories. One is the passenger vehicles and second one is the commercial vehicles, and collected data at different points in a day and tabulated the data. Now you need to verify whether the vehicle arrival is a random or not. So I'll show you the data sheet here. Now here we have a data sheet of vehicles, and to perform runs test, you need to click on analyze, then non-parametric tests, legacy dialogues, and here you have a runs. So select the runs, then select your variable, that is a vehicle. So now you need to see that how the vehicles are numbered. The cutoff point is not required because your observations are 2, 1. So as the dictomous, so we exclude this one, uncheck this, the median. Then you have to choose the custom. As your observations are 1, 2, that is the dictomous, you are given instead of a 0 and 1, you are given a 1 and 2. So here you have to enter the highest value among these two. So 1 and 2, highest value is a 2. So you enter the custom value as a 2. Then click exact. So here exact, continue. Then you have options here. So statistics, descriptive statistics and quartiles. Click continue. Once you select your variable, then given the custom input, that is 1 and 2, highest one of the two options, then click OK. So here you have runs test statistics. Test value is 2. Total cases 166 observations were there, and there are 84 runs. In the sense, for 84 times you find a different runs, like passenger vehicles at one time, then commercial vehicles another time. So likewise you have 84 runs. The z-score is 0.17, and SIMTIC sign test two-tail value is 0.97. So with this value, we fail to reject the null hypothesis and indicates that there is a randomness in vehicle arrivals at a toll plaza. Okay, so because here the check is your two-tail test, that is a power value is 0.987, which is much higher than your significance level of a 0.05. So because of which we accept the null hypothesis, saying that there is a randomness. So here our you can see here, the null hypothesis is that the sequence is random. So as the sequence is the random, the toll plaza manager can easily perform an inferential statistics. Here is another scenario. A bank asked this question in a questionnaire that is administered to customers who visited the branch. Are the customer responses follow randomness? Now the question posed is, do you use your cell phone for a financial banking transactions? So circle code 1 for yes and 2 for no. However, so with this we will be knowing that whether the customers who are arriving into the branch, so there is a randomness, because to infer the results you have to check, like if you have to analyze the chi-square test on looking at the association of a kind of respondents and their opinion or their usage of a banking transactions, you need to see that there is a randomness in your data collection. So here we have our data. Now here instead of a 1, 2, I coded this as a 0 and 1. Just which go to the variable, and here in the variable values, so you can see that 0 as a no and 1 for yes. If a customer is not using banking, that is a mobile phone for a banking and financial services, then no. If they are using, then yes. So just instead of there is a, in a questionnaire it is a 1 and 2, but here I just replaced it with a 0 and 1. Now to run your runs test, click analyze, then non-parametric test, legacy dialogues and runs. Already you calculated previous one, reset this. Now choose use mobile, then send this to the test variable list, uncheck median, check custom. So here your responses are 0 and 1. So 1 is the highest. So we enter the 1 here. Then exact, select exact, then continue, and your options. So your descriptive as well as quartiles. Click continue and click OK. So here are the results. You have a total 150 respondents. Then 50% is 1. So test value is 1 and G score is 0.7 and total significance value is 0.46 and exact sign test is also 0.51. These two indicates that we failed to reject the null hypothesis, which indicates that the customer arrival or the customers who are arriving into the branch and their usage of a mobile phone for banking services is random. So here we can say that the customer responses follow randomness. Yes, the customer responses follow randomness. As this follows randomness, you can use the inferential statistics on this data set. So as we said that null hypothesis, the sequence is a random. In both the cases which we observed here, we find that the sequence is a random one. So in both the cases, it is preferable to use the inferential statistics. Thank you. Thank you very much for listening to the lecture.